So in a previous class, we have seen Laplace transform and we solved all the gate question related to Laplace transform. So the main that is in your syllabus that will come in your gate examination from Laplace that we have already covered. There are few things which are remaining, that is how to solve heat equation and wave equation by Laplace. So they never asked a question from heat equation, wave equation, solving from Laplace. So, but that is in your syllabus. So we will see that later. Today I am going to start a new topic, that is a complex variable, because I mentioned this topic that I will start it today. The only that two things which is left in Laplace that we will cover in cover after the complex variable. And in last session, one of you asked me one question, sine root 3 by 2, and some function was there here, and you were asking the Laplace transform of this. So I told you to convert it in e to the power I theta form, but here I didn't see that this is a constant only, right? So if you're performing Laplace transform here, so constant will automatically come outside, and then you have to take the Laplace transform of this and this, that function of it. So that would be your answer because it is a constant number. Okay. So what we'll do after completing complex variable, we will practice more question in Laplace because there were very less questions asked in GATE. So we solved around 14-15 questions only. So better we practice more question to learn Laplace. The only keys to solve question from Laplace is practice. Because simple formulas they'll ask question. So as much as we'll practice, we'll be able to solve the questions. Today we are going to start complex variable, and this topic will take 2 sessions. So every time in GATE they ask about 5 to 6 marks question from this topic, sometimes more. So this is a very important topic. So this topic will cover first basics of complex number that you all already know. Then we will look analytic function in complex variables. Then third topic will be Milne-Thomson rule or Milne-Thomson method. Then Cauchy's integral theorem and formula. This is two concepts. One is Cauchy's integral theorem and one is Cauchy's integral formula. First one will be Cauchy's residue theorem, and before that we will see Taylor series and Lorentz series. Okay, so what will be the map here? Firstly, in basics, we'll start from very basic, like what is complex number and whatever you have learned in your house school, we'll just go through that. Then analytic functions are used to solve these kind of problems. Then we'll see what is an analytic function. Then Milne-Thomson rule that we will see. So This is Milne-Thomson. Milne-Thomson rule will tell you the differentiation of a complex number. So this will tell you complex number, how to differentiate or how to check the differentiability of a complex number. That is analytic function. Okay, these two are related, and these are related to differentiation of complex variable. And after that, whatever will be say, that will tell you how to get the integration of the complex number. Okay, these all formulas will be used to check the integration, and when they are asking about differentiation, you have to remind these two topics. So I'm dividing your chapter in 3 parts. Maybe they can ask about the basics. Suppose they are giving you some number and they are asking you argument of this number, or modulus of this number, or a limit of something they can ask. In analytic function, they will, and the Milne-Thomson method, what they'll do, they'll give you some number, some complex number, and they'll ask if this number, if this function is a analytic function or not. And then suppose they are giving you in the question itself, they will give you the real part and they'll ask you to calculate the imaginary part if the function is an analytic function, or vice versa. They can give you imaginary part and they'll ask you to calculate the real part. Okay, so these two topics are related to differentiation of complex variable. Other than all these, theorem and series are related to integration. Suppose they will give you some function, then they'll ask you to get the integration. So these formulas and theorem will help you to get the integration. Okay, sometimes why I'm telling you this roadmap, because sometimes you will get confused where what to use, when to use. So I'm telling you, when they'll ask you differentiation, you will think about these two topics. Then they'll ask you about integration, you'll think about these topics. Basics will be different. Okay, because when I was preparing, sometimes I used to try putting integral theorem into differential problem, so that you don't have to do. Just to remind, if they are asking about differential problem, use these two topics. If they are asking about integration, they will use these two topics. So today we will cover top 4, and if time will permit, we'll cover others also. Okay. So let's start from the basics. So how complex number comes into the picture. Suppose you are solving some kind of problems and you're trying to take the root of that problem, but it comes into negative. Like suppose in your real life problem, suppose you're solving some circuit in which there is a negative frequency also and positive frequency also, and when you're solving that kind of problem, you'll get some equation, and in that equation you're getting some value, some equation like this. Just to solve such kind of equation, we made one number which is whatever the root of root 5 iota. That is your imaginary number. That's how your complex numbers come into picture. To solve such kind of problems, where you get some equation like that. Okay, so how we represent your complex number? Suppose z is a complex number, so it will be represented by x plus iy. X will be the real part, y will be the imaginary part. Okay, so how we represent it on axis? On x-axis, your real part will be there. On y-axis, your imaginary part will be there. Okay, suppose some number is x plus iy. This much length is x, this much length is y. This will be your complex number x plus Iy. Okay. So this length will call as modulus of your complex number, which will be r is equals to x square plus y square. Okay. And this angle will be your argument. Okay. That will be theta is equals to arg of z tan inverse y by x. Okay, so this is very basic. I assume all of you know that. Then how to represent this in exponential form? So from here you can write cos theta is equals to x by r. Sin theta will be y by r. So your z will be r cos theta plus I r sin theta, or we can write it as r e to the power I theta. Okay, this is another form how you represent your complex number. Any doubts till now? So sometimes they'll simply ask you, they'll give you some big number or something, some big complex number. They'll ask you to calculate the modulus or argument. So what you have to do, you simplify this number in x plus I5 form, and then you will get the modulus and argument. Then few formulas and series that you should know. First, e to the power x, that will be 1 plus x divided by 1 factorial, x squared divided by 2 factorial, and so on till infinity. Then some formulas like you represent sin x in exponential form as e to the power x minus e to the power minus x divided by 2 sin hx. Cos hx as e to the power x plus e to the power minus x divided by 2. Then tan hx is equals to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. This is hyperbolic functions. How do you write sin theta? This is fifth. How do you write? Sin theta is e to the power I theta minus e to the power minus I theta divided by 2i. Sixth, cos theta will be e to the power I theta plus e to the power minus I theta divided by 2. Then some more like sin hyperbolic iota x will be I sin x. Then cos hyperbolic iota x will be cos x. Tan hyperbolic ix is equals to I tan x. Or circular also sin ix will be I sin hx. Cos ix, cos hx. Whatever will be for sin, same will be for tan. Tan ix will be I tan hx. Okay, so these two slides are for formulas that you should look.
Where we are using the sin ix and cos ix complex numbers in trigonometric function.
Sorry?
Where we be using the complex number and trigonometric. I mean sin ix.
See, I'm writing these formulas because when we will solve formulas like questions, you may need these formulas also. This is not important. These formulas are not that important, this much, but this is very important. Yes, I'm just telling you that you should know also. Suppose someone will ask you, then you should know. But these formulas will be very important for you. When we'll solve questions, you'll see that there are many questions which are dependent on these formulas. That was your doubt?
Actually, what I was saying is, do we have any? I mean, in any application like we will be having this kind of functions. In which kind of application we will be having this kind of function? You said that we are using in solving the circuits. We will be having this complex numbers. So
Okay, you're asking that where we are using sin h, ih, or cos hyperbolic function or tan hyperbolic function, right?
yes, ma'am.
Okay, so like in circuit problem, I used one example as a circuit problem. So suppose your circuit or whatever the problem you're using, your input and output is a simple sine cyclic this function. This is your sin x. Suppose whatever your input is, you're getting some hyperbolic sine function. That I don't know how to make the hyperbolic sine something like this. You're getting your output frequency in sine hyperbolic function or cos or tan. Okay, whatever the you don't know what will be the output, right? You're providing input, your output could be like your frequency could be like this. It could be a cyclic, hyperbolic, parabolic, any functions, right? So these things are useful in like electronics or electrical. In we are a mechanical students, so we never saw any use of hyperbolic functions or parabolic function even also in circuits or something. But when you solve higher order circuit problems, these kind of functions are involved in there. So what we are studying in our department, in mechanical department, is very basic level. We just know what are the hyperbolic functions, how hyperbolic and complex variables are related. So if simple problems will come, we will be able to solve. So that is why we are learning here very basic. Like now, I also even don't know like what will be the very high order hyperbolic sine function equations. But I know that I have that idea. Okay, what it could be. So that much is important for you also.
Ma'am, this type of scenario we can use in mathematics problem in software MATLAB. There are many options to solve this kind of problem.
Okay.
Ma'am, can we go to first slide, please?
Sure. This one?
Yes. At the end of the slide, you were telling that type of questions the gate is going to form. I was not I missed that. Can you repeat it?
This slide?
Not before starting formulas. You were telling that the type of questions
This one?
may be asked.
Okay, there are three types of question that they will ask in game. First type is question that they will ask from basics, very basics. Suppose they will give you one complex variable or complex function, and they will ask you to calculate the modulus or to calculate the argument of, or maybe the limit also. Okay. Second type of question, then they will give you one complex variable, and then they'll ask you if the variable is an analytic function or not. And suppose they will ask you if it is differentiable or not. Third type of, they will give you one complex variable and they will ask you to calculate the integration of that function. So first basics that we have seen, that you will be able to solve the basic question of that topic. Then suppose they are asking about the differentiation or something related to differentiation, then you have to think about these two topics: analytic function in complex variables and Milner-Thomson method. That I will tell you what it is. And suppose they are giving you some big function or big analytic function or non-analytic function, and then they will ask you to integrate. They will ask you the integral of that function. Then you'll use these three topics. Sometimes they directly ask, they'll give you one complex number and they'll ask you to convert it into Taylor series, and they will ask you to the coefficient of something in the Lorentz series. Okay, so these kind of questions will be asked from this chapter.
This is a separate Taylor and Lorentz series for complex.
This Taylor series and Lorentz series is simple. You know about Taylor series and Lorentz series, right? Suppose some number we have, so how we are convert that number into Taylor series number, we can say function. Some function is there. How can you convert that function in Taylor series if your function is a complex variable or an analytic function? That we will see in this chapter. Taylor series you may have learned in the calculus also, right? With Rajat.
Yes. Yes.
Okay. Here we'll involve the complex functions. How you will convert your complex functions in Taylor series and Lorentz series.
All right.
Okay. Okay. So what doubt was here? I think I was not able to tell you what you were asking, but that much I know, like where we use sine hyperbolic. Okay. So where will we? Okay, so next move on to singularity. So what is singularity? A point at which a function fz is not analytic will be called as singular point or singularity point. Okay, so let's see first what is analytic function. Okay, so a function will be called a function fz which is single valued and possesses a unique derivative with respect to z at all the points of a reason R is called an analytic function of Z in that reason. This is a book definition. What does it mean? That your function will be called, suppose some function is fz, it will be called as an analytic function if it is differentiable in a region, you can say C. Okay, so what will they do? A question will come. They will give you one reason. Suppose one circle is there, mod z is equals to 1. This is the equation of circle, right? So one reason is there, and then they will give you some function upon 1 upon z minus 1, suppose. Then they'll ask you if this function is analytic or not. So how to check if a function is analytic? If this function is differentiable in all this reason, then this function will be called analytic function. Okay. So tell me if this function is differentiable in this reason or not.
Ma'am, at z equal to 1, it is not defined, right? So,
Sorry?
since at z equal to 1, it's not defined.
Sorry. One more thing that I should add. It should be differentiable in this region and also on the periphery. And also on the periphery. So when we'll include the periphery, now tell me if the function is differentiable or not.
No, it's not differentiable.
Great. It is not differentiable. Because when you'll put z is equals to 1 in this function, then it will be not defined. Okay. So how to check if a function is analytic or not? Then there is one Cauchy-Riemann equations. So a function is, one more definition of for analytic function will be, a function will be called as an analytic function if it satisfies these two conditions. First is ux will be vy and uy is equals to minus vx. These are the Cauchy-Riemann equations, and ux, uy, vx, vy are continuous functions of x and y. Okay, what does that mean? Suppose some function is there fz, and some real part will be there which will be function of xy, then some imaginary part will be there which will be the function of xy. So ux will be differentiation of u with respect to x, uy will be differentiation of u with respect to y, same for v also. Vx will be and vy will be okay. So if suppose they have given you some function fz and then they are asking you if this function is analytic or not, then what you will do, you will check if this function is following these two conditions. If it is following these two conditions, this function will be analytic function. Now we'll solve one question on that. then we will understand. Suppose your function fz is equals to z square. They are asking if it is analytic or not. So what you can write z as x plus iy. Okay, so fz will be x plus iy whole square. Now we will solve this. Will be x square minus y square plus I to xy. Here your u will be this real part and your v will be this. So what are the equation? Firstly, you have to find ux. Ux will be 2x. Then uy. Uy will be minus 2y. Vx. Vx will be 2y. Vy will also be 2x. Okay. So now tell me if it is analytic or not. All these functions are continuous, right? So second condition is satisfying. First condition is satisfying or not?
Yes, ma'am, it is.
Satisfying.
Yes.
This is satisfying. So both the conditions are satisfying here. Conditions are satisfied. So we can call your fz is analytic. Okay. So
Ma'am, which means if these two equations are satisfied, f of z is analytic in the entire region because we didn't mention the region.
here it is, if everything is satisfying, that means it is analytic at everywhere. Okay.
Okay.
These two equation will tell you about everywhere. There will be no specific reason if this is satisfying these two conditions. If it is not satisfying, that there will be some reason in which your function is analytic. It will be not be analytic everywhere.
There will be some singularity here.
Yes, there will be some singularity here. Suppose your function will be z minus 1 or some z square plus 2 or something. So your singular point will be z is equals to 1. But suppose they are asking in the reason where your z is less than 1. Suppose in this reason they are asking if your function is analytic or not. So your singularity point is not inside this reason. Your z is equals to 1 will be somewhere here, suppose. It is not in reason. So in this reason, your function is analytic, right? So you'll say that your function is analytic in this reason.
But here we cannot directly use the CR equations, right?
Sorry?
When they are giving a particular region,
you can directly see the singularities here, right?
Yes.
Okay. Okay. Sometimes what they do, they will give you they'll give you one function and they will give you its real part, only real part or only imaginary part. Then they will ask you to calculate the other one. Suppose they are giving you real, then they will ask you to calculate the imaginary, or they are giving imaginary, then they'll ask you to calculate the real. So how we will do that? So there will be, in this method, it contains 2 points. First, when real part of analytic function uxy is given, and this is given, what your step 1? Your step 1 will be, firstly you find ux and uy. Then step 2 will be if you will write f dash z will be ux plus ivx, and you can write your vx as minus uy from because your function is analytic. So you can write f dash z is equals to ux minus I uy. Firstly, you calculated ux and uy because you have only real functions. Ux and uy you can calculate. Then you will write f dash z is equals to ux minus I uy. Okay. Then step 3 will be hello.
Yes, ma'am.
Is my voice breaking?
No, ma'am, it's clear.
Okay.
No, madam. Clear.
Then your third step will be you will put x is equals to z and y is equals to 0 in f dash z and integrate with respect to z to get fz. Okay. So the best way to understand these steps, we'll solve one problem. Question: fz is equals to u plus iy is an analytic function, and u is given as sin x cos hy. Then they are asking you to find fz. Okay, so what is our first step? You will find ux. So ux will be cos hy and cos x, and your uy will be sin x sin hy. Okay, now f dash z will be, this is your first step, ux and uy you found. Second step, you know that fz z is equals to ux minus I uy.
Excuse me, ma'am.
Yes.
Ma'am, differentiation of cos hy is minus sin hy or plus?
See, no. We are differentiating with respect to x, right? So in this term there is no x. So I wrote it as it is. I only differentiated sin x. That is cos x.
In uy.
Uy. For hyperbolic, it is not minus, right?
Actually, I was not sure. I just wanted to confirm it.
No, it is not minus.
Okay.
Then we can write f dash z is equals to ux minus I uy. Now we will put the values. F dash z is equals to cos x cos hy minus I sin x sin hyperbolic y. Now the third step is put x is equals to z and y is equals to 0 in f dash z. We'll put x is equals to z here. This will be cos z and y is equals to 0. Cos 0, 1. Here sin 0, this is sin x and this is sin 0, 0. Here f dash z will be cos z. Then what we have to do? We have to integrate this with respect to z. Cos z dz. When you'll integrate, you'll get fz is equals to sin z. Now, what will be your imaginary part? So you can write u plus iv is equals to sin x plus iy. So your u plus iv will be sin x cos iy plus cos x sin iy. And you can write it as sin x, and you can write cos iy as cos hyperbolic y plus I. You can write sin iy as I sin hyperbolic y. So it will be I cos x sin hyperbolic y, u plus iv. Now we can compare real part with real part, imaginary part with imaginary part. So from here you will get your v as cos x sin hyperbolic y. This will be your answer. Any doubts in there?
Ma'am, please repeat again.
Okay. So in this question they gave you one function fz is equals to u plus iy, and in that they gave you real part u, which is sin x cos hyperbolic y. Then they asked you what will be the fz. Fz we have found here itself, but I moved to one more step and showed you how to get the imaginary part also. So what we do, your first step, when you are getting real part, you get ux and uy. Ux and uy is differentiation of u with respect to x and with respect to y in uy. Then you will get this. And then your f that z will be ux minus I uy. Then you will put the value of ux and uy here, and this will be your second step. In third step, you will put x is equals to z and y is equals to 0. Then you will put these two values. You will get one more equation that will be in terms of f z dash dash z, which is f dash z is equals to cos z. Then you will integrate this equation with respect to z, and you'll get the value of fz that they asked in the question. But we move to one more step. We calculate the imaginary part. So you can write a function in terms of this u plus iy is equals to sin x plus iy. We simplified sin x plus iy. You can write cos iy as cos hyperbolic y and sin iy as I sin hyperbolic y. Then you will compare your real part with the real part and imaginary part with the imaginary part. That's how you will get the imaginary part. Okay.
Okay.
Okay. The second method of Milne-Thomson. Where is the person? Okay. Second. When your imaginary part is given in the question, they're asking you to calculate the real part or the function. Imaginary part is given of an analytic function. So same steps. First, step 1, find bx and by. Second, now how you will write f dash z? It will be in terms of vx and by. So you can write, firstly you'll write ux plus ivx. You can write ux as vy. That is the condition of an analytic function. So you'll write it as Vy plus I Vx. F dash Z is equals to. This will be your step 2, and your step 3 will be again put x is equals to z and y is equals to 0 in f dash z and integrate with respect to z to get fz. Okay. Again, we will see with one question. Question is fz is equals to u plus iv is an analytic function and v is given as 3x square y minus y cube. Then what will be fz? In next session, I'll tell you the shortcut to use this method. You don't have to follow all these steps. You can get the answer in one line only. That I will tell you in next session. So, what will be your Vx with respect to x? 6xy. What will be your Vy? 3x square minus 3y square. This is your step 1. Step 2 is equals to f dash z is equals to Vy plus I Vx. So we'll write it here 3x square minus 3y square plus I 6xy. This will be your f dash z. Third step is put x is equals to z and y is equals to 0. It will be f dash z. Then you will put z here and z is here. This term will be 0. This term will be 0 and this term will be 0 and this term will be 3z square. Okay. Now we will integrate with respect to z. It will be fz is equals to z cube. So this is what they asked. If you want to calculate the real part, you can write u plus iv is equals to x plus y whole cube. And we'll solve this x cube minus iy cube plus 3xiy x plus iy. U plus iv is equals to then x cube can take common minus 3xy square plus I 3x square y minus y cube u's plus iy. So from here if you will compare real part with real part, imaginary part with the imaginary part, your real part will be x cube minus 3xy square. Okay.
Ma'am, please open the previous slide.
Sure.
Ma'am, here in the question, step 3, ma'am, in the question, x equal to z or y equal to 0. Ma'am, this condition will be given in the question.
No, this is your step. This is your
Okay.
Milne-Thomson bracket. There are 3 steps that you have to follow to get the imaginary part or real part.
Ma'am, in previous question, there will be fz equal to 2 and
No, that was not 2. I wrote x is equal to z. Sorry. Right. This is x is equal to z only. This is your step 3. Firstly, if they are giving you how to remember this, if they are giving you the real part, Then you differentiate your real part with respect to x and with respect to y. Then you put your real part differentiated with respect to x and y in this equation. F dash z is equals to vx minus iuy. And then your third step will be you have to put x is equals to z and y is equals to 0 in f dash z. Same steps you will follow when they will give you imaginary part, but you have to do all these things for v. Like you have to find vx and vy, and then you have to put it in this equation because you know vy and vx. If you in this you knew ux and uy, that's why you use this equation. In this you will use vx and vy, that's why you will use this equation. Then the step 3 will be the same. You have to put x is equals to z and y is equals to 0 in f dash z. When I'll tell you the shortcut, you'll get to know why we are putting x is equals to z and y is equals to 0 in this map. But this is the method that you have to follow.
Okay.
This method
Ma'am,
is
there
called
was
as
an alternate method where we use the CR equation. So, does that method have any limitation against this, or?
Can you repeat? What's your Riemann equation?
To solve this type of equation, there was a formula that we use the CR equations. We equalize the ux is equals to vy and uy is equals to minus vx, then integrate.
No, there will not be any limitation because those equations are for analytic. If this function is analytic, that means it is satisfying those two equations already, and there is no boundation. This function is analytic everywhere, so there is no limitation for this function. If they already mention that this function is analytic, then we have to assume that this function is analytic everywhere.
Okay, ma'am.
So complex variable. This looks a very small chapter, but this is actually a very big chapter, and they can form questions from anywhere. From basics also, they can form very tough questions. So what we'll take 2 sections more to practice questions. Okay, I'm going very
Ma'am?
slowly. Yes.
And from basics, what are the types of questions expected?
Okay. Suppose they'll ask you calculate the limit z tends to 0 z bar by z. If they'll ask from limit. Okay. Normally, suppose they'll give you x minus iy upon x plus or x square plus iy square. Calculate the modulus or calculate the argument of this value. This I have written very simple. They can write some complex values here. Or mostly they'll give you to calculate limit, or they can use that omega also, that you remember 1 omega square. So that also they can ask. So we will practice basic questions also. Then I'll show you the gate question. You'll understand what kind of question they ask.
Okay.
So till now, what we covered. Okay, we covered the basics. We covered the analytic function, and we covered the Milne-Thomson model. Okay. So it looks very small topic, but it is actually a very big topic. When we solve the question, then you will see. So 3 topics we have covered. Now we will move to integration of complex number. Okay. So first rule to get the integration of a complex function is Cauchy's theorem. So what this theorem says, if fz is equals to analytic within and on the boundary of a simple closed curve C, then integration of fz in that region C will be 0. Okay, one thing that you understand now, why we always integrate or differentiate a complex function in a region. Why? Because your complex function is a region. Your real numbers will come on here. Your imaginary numbers will come on here. So whenever we'll try to differentiate or integrate a complex function, we have to differentiate or integrate it around some region. In a real function, how we differentiate? We differentiate with respect to x, or we differentiate with respect to y. What is the differentiation actually? Suppose you have some function, so you'll differentiate with respect to, suppose you have some function f x y. So if you're differentiating this function with respect to x, that means you're trying to get the value of this function if you are moving along the x direction. Or if you're differentiating this function with respect to y, that means you want to look how your function value is changing when you're moving in the y direction. Okay, same way in imaginary number, if you're differentiating if differentiating is a complex function, if you have to check the area. Okay, so that is why I have written, if a function is analytic within a region and on the boundary of a simple closed curve, then the integration of that function in that region will be 0. Okay, now how to use this theorem? Let me write one question. Integration of sec z dz in the closed curve of C, and your closed curve is C is modulus of z is equals to 1. This is a question of circle, okay, that you all know, I assume. So for sec z, what will be the singular points? Tell me. Sec z is what? 1 upon cos z. And if your z will be 90 here,
Odd
this
multiples of
value
pi by 2.
yeah, right. If your z will be 90 here, it will be infinity. So singular points for your function will be z is equals to plus minus pi by 2, then plus minus 3 pi by 2, and so on. Calculate divide 3.14 divided by 2, then what will be this value? Tell me, pi by 2?
1.57.
Okay, this will be 1.57. So what the reason they have given? The reason is one circle. This is the equation of a circle whose radius is 1. So this will be your plus 1, this will be your minus 1, and all your singular points, this point is 1.57. Where this point will lie? This point will lie outer region of this circle. So all your singularity points will be in the outer region. So what they are asking? They are asking the integration in this region. So in this region, there will be no singularity point. So the integration of this will be 0. That what your theorem says. Very good. Okay. If fz is analytic within and on the boundary of a simple closed curve, then the integration of that function in that region will be 0. Okay. Any doubts?
Can you explain the graph that you have plotted? I mean, points.
Where?
You have drawn a graph like -1, and you have point out the points.
Okay. See, this is a function sec z. Sec z will be 1 upon cos z, and cos 90 will be 0. So all these points at pi by 2 plus minus 3 pi by 2 plus minus, your function value will be infinity. So these points will be singular points. Okay. So what theorem says, if your function is analytic within the region or on the boundary, then integration in that region of that function will be 0, will give the 0. So what we did here, this is the reason. Mod z is equals to 1. This is nothing but a equation of a circle. Okay, if you will solve this, it will be under root, mod z will be under root x square by y square is equals to 1. It will be x square plus y square is equals to 1. This is a equation of a circle with the radius of 1. So I draw a circle whose radius is 1. This is your reason. What they are asking? They are asking you to calculate the integration of this complex function within this region. Okay. So what our theorem says, if no singularity points are lying within this region, then the integration of your complex function will be 0. So all singularity points, if you will calculate the numerical value, pi by 2 will be 1.57. 3.14 divided by 2 will be 1.57. And all other points are greater than this. So all the points will be lie here, or somewhere here. So no singularity points will be lie within the region. So according to your Cauchy theorem, integration of this function will be in this region will be 0. So your answer will be 0 here. Understood?
Okay.
So this was the first theorem. So this very easy question will be formed. All you have to check the singularity points. If your points are lying within the region, then we'll move to other formulas. If your singularity point doesn't lie within the region, that means integration of that function will be 0. Now move on to next theorem. Suppose singularity points are lying within the region. Okay. Then the second thing is Cauchy's integral formula. This is a general formula. If fz is analytic within and on the boundary of a simple closed curve C and A is any point inside the C, then integration of fz divided by z minus a dz will be 2 pi I f a. This is one formula. Another formula will be integration within a region C fz divided by z minus a n plus 1 dz will be 2 pi I divided by n factorial fn a, where your fna means dn by dzn fz at z is equals to a. Okay, so this looks very complex. So what we'll do, we'll take one question and understand. So what this theorem is saying, if some function is analytic within and on the boundary of a simple closed curve C, then A will be any point inside the C for which integration of fz divided by z minus a dz is equals to 2 pi I fa. Okay. Okay.
Yes.
Singular form. This will be a note. Now we'll see both the formulas with one question. The question is, they're asking you to calculate the integration of sine pi z square plus cos pi z square divided by z minus 2 z minus 4 dz, where c is equals to mod of z is equals to 3. Excuse me. Again, this is a equation of a circle. Firstly, we'll just draw. This is your region 3 minus 3. This is your circle and they're asking you to integrate this function within this region. So what is the formula? Firstly, you check the singularity, where this function will be singular. Tell me.
I'm at 2 and 4.
Okay. Where it will be singular within the region?
At point 2.
Very nice. So your function will be non-analytic at z is equals to 2. Okay, this is your singularity point within the region. Correct? Everyone get it that?
Yes.
Okay, so how you will write your integration now? You will write it as sine pi z square plus cos pi z square divided by z minus 4 divided by z minus 2 dz. Now this integration term is in the form of formula. See, A is a singular point and there is one function fz. Now you can easily calculate the integration of this function. It will be 2 pi I fa. What we have to write here? This will be equals to 2 pi I fa. A will be 2 here. You have to put 2 in this. So it will be sine four pi plus cos 4 pi divided by 2 minus 4. It will be 2 pi I. Sine 4 pi will be 0. Cos 4 pi will be 1 divided by minus 2. Your answer will be minus pi I. So integration of this whole function will be pi I. Any doubts in that? Any doubts?
Ma'am, please repeat once again.
Sure. So this was the Cauchy's integral formula. If fz is an analytic function on the boundary of a simple closed curve and a is a point inside the curve which is a singular point, then the formula is integration of fz divided by z minus a dz will be 2 pi I fa. So what we did here, firstly this is your function, and the reason is the circle mod z is equals to 3. What I did, I drew a circle. Then here you can see that this function is not defined at 2 points. Firstly, if you put z is equal to 2. Second, if you put z is equals to 4. But what we are doing here, we are integrating this within a reason. So we'll check in at what point this will be non-analytic within the reason. So z equals to 4 will lie outside of this reason. So that is not our whole point here. Second, z is equals to 2 lies inside the reason. So at that point, you cannot integrate the function. That's what it means. That's what singularity means. You cannot integrate this function at z is equals to 2 because in this reason, because that point lies inside the reason. So now we converted our function in this form. Here also, in this formula also, your function is, you cannot integrate your function at z is equals to 2 because a is a singular point. Here your singular point is z is equals to 2. So I have written this as in this form: sine pi z square plus cos pi z square divided by z minus 4. Now this is your whole fz and this is your z minus a. When you converted your integral in this form, now you know how to integrate this. So your answer will be 2 pi I fa. Okay, integration of this will be 2 pi I fa as Cauchy's integral formula. So what we did, we simply wrote 2 pi I, and in this function, this is your fz now, we put z is equals to 2 or z is equals to a. So when we put z is equals to 2, it will be sine 4 pi plus cos 4 pi divided by z minus 4. Then you solved it, then your answer came as minus pi I. Here.
Ma'am, here z is equal to minus 2. Can we consider that or not?
Sorry?
Ma'am, here z equal to, where we have right z equal to 2. So here we can singularity points, we can consider here z equal to minus 2 or not.
Z is equals to minus 2 is your singularity point, right?
Yes, ma'am.
That's why we have written z minus 2 here.
Madam, can we show the z equal to 2 points on minus 3 or 3? Which side, madam?
See, the formula says within the boundary, on the boundary also. So, if it is not, if your singular point lies on the boundary also, then also you have to take it.
Okay, madam. Okay.
Okay. So next formula was for.
And so it must be strictly outside.
It should be strictly outside. completely outside. So next formula is this. Suppose your z minus a is in some power. So we'll solve one question on this also. Question says integrate this function e to the power 2z divided by z plus 1 whole to the power 4 dz, where c is mod z is equals to 3. Again, first draw your reason. What will be the singularity point here? Z is equals to minus 1. This lies inside the circle. Now, simply, you can write a formula. Integration of fz divided by z minus a n plus 1 dz will be 2 pi I n factorial fna. Okay. So here your n is 3 and your a is minus 1. So you can write it as 2 pi I 3 factorial f triple dash. If you'll put z is equals to minus 1 in this function, firstly what we'll do, we'll differentiate. Fz is equals to e to the power 2z, f dash will be 2 e to the power 2z. My 2 and z is little confusing, so when I say, try to listen. Fz is equals to 4 e to the power 2z, f triple dash z will be 8 e to the power 2z. Okay, now you have to put f triple dash minus 1 will be 8 e to the power minus 2. So it will be 2 pi I 6 into 8 e to the power minus 2. So the answer will be 8 by 3 pi I e to the power minus 2. So integration of this function will be 8 by 3 pi I e to the power minus 2. Any doubts in this?
Ma'am, if we take here, if we take mod of z equal to 2, so we can, this point will be lies a equal to minus 1 or.
See, if you have taken mod of z is equals to 2, again this will be your reason, and again this point will lie inside. What if it is outside? Suppose this is your reason. Suppose the singularity point is lying outside. So what will be the integral?
0.
0. Very nice. So that was the first theorem, Cauchy's integral theorem. If your point is lying outside the region, then your integral will be 0. If it's lying inside the region, then this is the first method that we have seen how to solve with the use of Cauchy's integral formula. Okay.
Even if mod z equal to 1, we'll get 8 by 3 pi I.
Yeah. Yes. Even if it's if it lies on the boundary, you will take it as a singular function.
Why did we take fz equals to e to the power 2z only?
Sorry?
And why did we take fz equals to e to the power 2z and not the z plus 1 raised to power 4?
That is the formula, right? If you put z is equals to 1 in this, your function will be tending to infinity, right? The function is not defined at z is equals to minus 1. So your singular point is here.
For differentiating, we take e to the power 2z only.
Differentiating, sorry. For integration, we are taking only e to the power 2. You are saying that we are putting only z is equals to -1 in this only, right? That is your doubt, right?
No, ma'am. I'm saying in the right hand side there is you found the f triple dash z on the right hand side, extreme right.
Okay,
For that we take e to the power 2z.
Okay, I got you down. So the formula says that integration of fz divided by z minus a, where z minus a is a singularity point. So this term was your singular. This is giving you a singularity point. So that's why we are taking it outside, and only function will be this one. Whatever is making your function, whatever is making your function non-differentiable or non-integratable, that you will take out as a singular point. That you will not consider as a function. That's why we are adding this here. This is nothing. If you will derive his formula, we will derive Cauchy's formula. In this, we are eliminating the singularity points, and we are differentiating in or integrating in other reasons. That is why we are not taking this in your function. We will only take whatever which is not at a singular point. Like in this question, we didn't take z minus 2, but we took all other the values of the function which is present. Only the singularity point we didn't take. And here also, this is his formula. Okay?
Okay, ma'am.
Okay. So, till now we covered.
Ma'am, just a small doubt.
Sure. Tell me.
Ma'am, even if we had a region like z is equal to 2 in the previous question, whether that integration would have been same?
This question? What is
Yes, ma'am. No, ma'am. Next one.
this one?
Ma'am. Even if we had like z is equal to 2, then whether we had the same integration 8 by 3.
Yeah. Same. If the point is lying within the region, then that will be a singularity point.
Okay, ma'am.
क्या मतलब just check कि तुम्हारा function किस point पे infinity दे रहा है या define नहीं हो रहा है. That will be a singularity point.
Yes, ma'am.
Okay, so we have covered these 4 parts. Yes.
Ma'am, during the definition of analytic function, we had mentioned single valued and unique differential. Can you just kindly explain those 2 phrases once?
See, let's not talk about a complex function. Let's talk about simple function. So function is differentiable. How you call a function is differentiable if its limit is existing. Suppose this is some point at 2 plus also, at 2 minus also, and at function itself, right? These all value should be same, right? Then your function will be differentiable. That was the definition of the differentiability, right? The same way in complex function, it is saying that it will possess it will possess one value, one differentiable value within the whole region. It is the same only. Some function will be continuous if your limit is existing, left side also, right side also, and it will be same as the function value at that point. Suppose this point is it. This will be continuous and differentiable. Same for complex function. it is the same meaning. This all will give you the same value before the limit, after the limit, at the point also. The values will be same, then it is a continuous and differentiable, right?
Yes.
The same is for complex function, but now we are going to look for a reason. In all the reason, wherever you will differentiate that function, it will give you the same value. That is why we are differentiating it in a reason, but we are getting one value only. That what that line means.
Okay.
Okay, so we covered 4 topics. What I suggest you solve question on these topics. Residue theorem and Taylor series we'll cover in next session, and we'll cover all the questions also. So I want to ask you all, after complex variable, Rajat will take numerical methods. So I think all the topics in engineering mathematics has been covered. So what do you want next? You want to solve the problems of mathematics, or you want any other subject?
Ma'am, actually in Laplace you told that 2 topics were there.
Laplace will be there after that. Next session also I'll take. After that also 2 sessions I will take. We will practice Laplace and complexity. What do you want to do after that?
Ma'am, numerical
methods. On our
methods.
site also.
If there are any numerical methods as well, problems we can do. Probability.
Probability. But probability is covered by Rajat, right? You want to solve question, then we can solve.
Yes, ma'am. Questions.
Okay, then I will update on website. I need to update what I am gonna teach next or discuss next. So that's why I'm asking you.
And actually in the matrix, actually there is a topic called diagonalization. Right?
Diagonalization is not in your syllabus, but we can see that.
Yes, actually in engineering sciences it is there.
Okay. It is a very big topic also, but yeah, basic you should know. That I will tell you.
Okay.
So you want to stick on the mathematics, or you want to start something else?
Ma'am, can we also have the lectures on that cognitive aptitude, like English?
Sorry?
Are we having lectures on that cognitive aptitude 50 marks in English?
What are you asking? Bit louder, my headphones.
Ma'am, I was asking, are we having the lectures on cognitive aptitude and that English?
Okay. English and aptitude, I think no one is taking that. We have been asked to take the courses of core mechanical only. So I'm not sure if we'll take sessions on aptitude and English. I will ask my coordinator. If he will allow, then I will let you know. We can practice English and aptitude.
If we could practice problems from other departments as well, it will be better.
That we will do.